The universe is bigger than your mind can hold, bigger than numbers can describe, bigger than anything the human brain was ever designed to imagine. When we talk about the size of the universe, we're not just talking about distance, we're talking about a scale so large that it breaks intuition, bends imagination, and leaves even scientists silent. Welcome to Cosmicnova. Today we explore how big the universe truly is. We begin with the familiar. Earth is 40,000 kilometers around, a world full of oceans, mountains, and life. From space, it seems enormous. But in the cosmic scale, Earth is a grain of dust floating in a vast, endless ocean. Our entire solar system stretches nearly 5.5 billion kilometers from the Sun to Pluto. It takes sunlight more than 5 hours just to reach the edge. And yet, if the Sun were the size of a basketball, Earth would be a small grain of sand 8 meters away. Now zoom out further. Beyond Pluto lies the interstellar void, a cold, empty stretch of space separating us from the next nearest star, Proxima Centauri. It's over 4 light-years away. If our solar system were a coin, the distance to the next coin would be hundreds of meters. The Milky Way galaxy is home to hundreds of billions of stars. It stretches 100,000 light-years across, so wide that even if you traveled at the speed of light, it would take you 100,000 years to cross it. Every point of light you see in the night sky belongs to this one galaxy. But our galaxy is just one among trillions. When the Hubble Space Telescope pointed at a tiny patch of empty sky, a spot the size of a grain of sand held at arm's length, it found over 10,000 galaxies hiding in that darkness, each one filled with billions of stars. The observable universe, everything we can see, stretches 93 billion light-years across. Not because the universe is 93 billion years old, but because space itself has been expanding, stretching light, pulling galaxies apart faster than the speed of light. But the observable universe is only what light has had time to reach us from. Beyond that horizon could be more galaxies, more clusters, possibly an infinite cosmic landscape. The universe may be so large that our observable bubble is just a tiny zone in a much bigger reality. And yet, all of this may only be the beginning, because some theories suggest that our entire universe, all 93 billion light-years of it, could be just one bubble among countless others in a massive cosmic foam. If that's true, then the size of our universe isn't just enormous. It's irrelevant. The true scale might be far stranger. As we zoom farther out, something remarkable begins to appear. The universe is not random. It has a structure, a vast, interconnected pattern stretching across unimaginable distances. Galaxies aren't scattered like grains of sand. They form threads, knots, and walls that span billions of light-years. This is the cosmic web, the skeleton of the universe. Each glowing filament of the cosmic web is made of galaxies, millions of them, drawn together by gravity. At the intersections, immense clusters form, each containing thousands of galaxies packed together. If you could stand at one of these intersections, the night sky wouldn't be dark. It would be filled with countless suns. Between the filaments lie enormous voids, regions so empty they challenge imagination. Some voids are hundreds of millions of light-years wide with almost no galaxies inside them. These dark regions stretch across the universe like vast cosmic deserts. Our Milky Way belongs to a massive structure called the Laniakea supercluster, a gravitational continent of roughly 100,000 galaxies. If galaxies were cities, Laniakea would be the size of a nation spanning light-years across. And even this enormous structure is only one piece of a much grander map. Superclusters themselves stretch for hundreds of millions of light-years. They form sweeping arcs and walls across the universe. One of the largest known structures, the Hercules Corona Borealis Great Wall, is so massive it spans 10 billion light-years, nearly 1/10 of the observable universe. But the universe isn't just big, it's growing. Every galaxy is moving away from every other galaxy because space itself is expanding. Some galaxies are receding so quickly that their light will never reach us. Not now, not ever. They are disappearing beyond a horizon we cannot cross. Imagine standing on a shore, watching ships sailing over the ocean. Eventually, they pass beyond the horizon, not because they vanished, but because Earth's curvature hides them. In the same way, the universe has a cosmic horizon. Beyond it lies a realm we can never see, not even with future telescopes. Beyond that horizon could be more galaxies, more clusters, endless cosmic web, regions with different physics, or even the edge of a much larger structure. If the observable universe is a bubble, then beyond the bubble may lie more bubbles, each its own universe. Some theories propose that the universe may be infinite. Infinite galaxies, infinite stars, infinite worlds, infinite possibilities. If that's true, then every direction stretches forever, with no edge, no wall, no boundary, just an endless cosmic ocean. But even if the universe is infinite, a deeper question remains. How did it all begin? What force created this enormous cosmic structure? And how can something so vast emerge from nothing? To understand the true size of the universe, we must travel back to its very beginning. To understand the true size of the universe, we have to go back, not millions but 13.8 billion years, to the very moment everything began. The universe we see today, with its galaxies and cosmic webs stretching across billions of light-years, started from something smaller than an atom, a tiny point of unimaginable energy, where space, time, and matter were compressed into a single cosmic seed. In an instant, that tiny point expanded, not like an explosion, but like space stretching faster than the speed of light. This process, called inflation, blew the universe up to the size of a galaxy in a tiny fraction of a second. Space wasn't expanding into anything. It was creating itself, forming the foundation for everything that would ever exist. For the first 380,000 years, the universe was too hot for light to travel freely. Everything was a glowing fog of particles smashing into each other. But when it finally cooled, light broke free, and the universe became transparent. Today, we can still see this ancient light as the cosmic microwave background, a faint glow filling the entire sky. Over billions of years, gravity pulled matter together into stars, then galaxies, then clusters. The cosmic web emerged from tiny quantum ripples in the early universe, wrinkles stretched during inflation. Today, those wrinkles have evolved into structures spanning hundreds of millions of light-years. But as the universe grew, something unexpected began to happen. Its expansion started speeding up. Galaxies weren't just drifting apart. They were racing away faster and faster. A mysterious force called dark energy is pushing the universe outward, stretching space itself like an ever-growing fabric. Because expansion is accelerating, trillions of galaxies are already beyond our reach. Their light is stretched until it disappears into darkness. Even if we could travel at the speed of light, we could never catch them. Every second, more of the universe becomes permanently unreachable, slipping across the cosmic horizon. In the extremely distant future, trillions of years from now, galaxies outside our local group will vanish from sight entirely. The night sky will grow darker, stars will die, black holes will evaporate, and the universe may eventually become a cold, empty expanse filled with nothing but fading light and scattered particles. But that may not be the only ending. Some theories predict the universe might someday reverse its expansion and collapse back in a big crunch. Others suggest it might tear itself apart in a big rip, where even atoms are stretched to nothing. Or perhaps new universes bud off from ours in an endless cosmic cycle. Whatever the ending, one truth remains. The universe we see, 93 billion light-years wide, is only the observable portion. Beyond that horizon lies a cosmic wilderness we may never witness. The true universe may be hundreds of times larger, or infinite. We live inside a vast cosmic bubble, surrounded by mystery on every side. The size of the universe is not just a number. It's a reminder of how small we are and how much remains unexplored. Every galaxy, every cluster, every cosmic web we discover deepens the mystery of existence. The universe is larger than we can imagine, and larger still beyond that. Thanks for watching Cosmic Nova. Until next time, keep exploring the unknown.